Today I'll do questions that have to do with monomials and polynomials, and operations with monomials and polynomials. Let's start with this first question. It says, find the degree of each monomial below. So you see I've written here the definition of a monomial, just to remind you. A monomial is a single term product of a number and variables raised to non-negative powers. Notice that these A, B, and C, D examples are monomials. Now this question asks us to find the degree of a monomial. So what is the degree of a monomial? Okay, the degree of a monomial is equal to the sum of its variable exponents. So let's look at this first problem here. 2x. Again, 2x is a monomial. It's a single term product made up of the factors 2 and x. So we need to find the degree of this monomial. To find the degree, we need to find the sum of its variable exponents. So I look at this, and what variables do I see here? The only variable I see is x. And what is the power of x? Well, the power of x here is like 1. We know that any number to the 1 power is itself. So 2x is the same as 2x to the 1 power. I write this so we can be clear when we see or say that the degree of this monomial 2x is equal to 1. So you see we have to find the sum of its variable exponents, but here we only have one variable exponent, so we don't have to add it to anything. We just know that the degree of this monomial is 1. Let's go to B. B, we have another monomial, and this monomial is made up of 3x squared and y cubed. This one will be a little bit harder, if you will, than the first one because we now have two variables. So we have two variable exponents which we need to add. So we know by adding 2 plus 3 that equals 5, and consequently the degree of this polynomial, 3x squared y cubed, is 5. Cool. Let's go to C now. C is just the number 7. So, is this even a monomial? Notice this is a monomial. This is like the monomial 7x to the 0 power. So, we know that any number we could say is like some variable to the 0 power because any number to the 0 power is just 1. So, what is the degree of this monomial here, 7x to the 0 power? Well, notice our only variable exponent is 0. So the degree of our monomial is 0. Okay, let's look at part D. We have a squared b c to the 7th power d. So this is again a monomial made up of only variable parts this time. Or you can think of this and the number 1 multiplied with the number 1. In any case, we can find its degree. So notice that by adding 2 plus 1 plus 7 plus 1, or 2 plus 1 plus 7 plus 1, which equals 11, we know that the degree of this monomial is 11. Great. The next problem we'll talk about has to do with the degree of a polynomial in one variable. Let's read it together. It says, find the degree of each polynomial below. We have 4 examples here. Let's talk about those examples. Before we do, let me just remind you what a polynomial is. It's a finite sum of monomials. So when we add and subtract monomials, we have a polynomial. And the degree of a polynomial in one variable is just equal to the highest degree of all of its terms. So whichever term has the highest degree, that will be the degree of the polynomial. The degrees will be the same. Let's go ahead and see part A. Part A says x plus 1. Notice that this is a polynomial. In this case, this is a binomial, or a 2-term polynomial, that is made up of the monomials x and 1. So we can find the degree of this polynomial by looking at the degrees of each of its monomial parts, or each of its terms. So notice, what is the degree of x? Well, the degree of x is 1. So I'm just going to put a 1 down here, so we can remember that. And how about the degree of 1? Well, remember the degree of any any number or any constant, anything without a variable, with no variable part, will just have a degree of 0. And you can think of that as 1 times any variable to the 0 power, 1 times x to the 0 power. So we look at this and we can conclude that, well, the highest power here is 1. So the degree of our monomial here, or sorry, the degree of our polynomial here is 1. Great. Let's see B. So B, notice this first term has a degree of 2, this second term has a degree of 1, and this third term has a degree of 0. I know that the highest of those degrees is 2, so I know that the degree of my polynomial is 2. In C, what do we have? Well, notice that we have 7x to the 5th, the degree there is 5, 12x to the 7th power, the degree there is 7, the highest degree, or the highest degree of all terms is 7, so we know that the degree of our polynomial is also 7. How about this guy? This is a trinomial of degree 3. So notice that this first term has a degree of 3, this second term has a degree of 1, and this third term has a degree of 0. By looking at all those terms, we can see that 3 is the largest, or the highest, the greatest. So we can say that the degree of the polynomial is 3. Alright, the next problem I'd like to discuss has to do with operations with monomials. Let's read this first question here. It says, perform the indicated operations of monomials and simplify. Answers should be written with positive exponents only. So let's look at part A. It has 3x plus 2x minus 7x. So notice here that we have operations with monomials. We have 3 monomials here. We can combine these monomials using certain operations. And the way we do this is we think about this as reverse distribution. And we want to end up basically just adding and subtracting the number parts of x and multiplying that by x in the end. Notice that this is the same as 3 plus 2 minus 7 all times x. So, for example, if we reversed and distributed x into all these terms here, we would have 3x plus 2x minus 7x. Why do we write it in this manner? The reason we do this is because we can now combine what's in the parentheses here. Notice we could add 3 to 2, that's 5, and then subtract 7, that would be negative 2. So we have negative 2 times x, or just negative 2x. And that would be our solution in that case. Let's go ahead and look at B now. We have 4k times 2k squared. So now this will, notice we have 2 monomials, 4k, and the other monomial, 2k squared. We're asking to multiply, the operation here is multiplication. So let's multiply these together. Now when we multiply monomials like this, notice that monomials are products themselves. They're products of numbers and variables. So what do we have here? We have a product of products. And we know that multiplication is both associative and commutative, so order and grouping does not matter. So we could rearrange these multiplications. So we know, for example, that this is the same as just 4 times k times 2 times k squared. Now the reason I write it like that is so now you can be clear, it doesn't matter which way we write this. We could write this as 4 times 2 times k squared. And why is it nice to write it this way? It's nice to write it this way because we can see that, well, 2 times 4 is 8, and k times k squared is k cubed. So we have 8 times k cubed. And that'll be our solution. Okay, let's go ahead and look at part C here. We have 13r cubed t to the 7th divided by 34r to the 5th t squared. So see, we have the quotient of 2 monomials here. So how can we solve this problem? Well, the way we like to do it is similar to the way we like to do products of monomials. What I'd like to do here, as I did in the previous problem, is basically put my number parts together and my variable parts together. In particular, I'm going to put my numbers together, my r's together, and my t's together in 3 fractions. I'm basically going to break up this fraction into a product of fractions. See what I mean? This is the same as 17 divided by 34 times r cubed divided by r to the 5th times t to the 7th divided by t squared. Now I like to write it this way because then I can maybe know to use the quotient property of exponents to rewrite these things, or at least I can see what will cross out easily. This is not a necessary step. In any case, we could write that this is equal to 1/2 r cubed over r to the 5th is 1 over r squared, and t to the 7th over t squared is t to the 5th. At this step, we can combine this into a simpler quotient of monomials, t to the 5th over 2r squared. And that's our solution for part C. Okay, let's look at part D now. So part D, we have 6x times 6xy divided by 9x cubed y z cubed. So notice in this case, what's happening? Well, we have a product of monomials in our numerator, and then we're going to divide that product by another monomial, which is our denominator. So let's begin first by, how about computing the product of these first two monomials in the numerator, and then we'll take the quotient after that. So we'll begin by saying that this is the same as, well, 6x times 6xy. Again, we have a product of monomials. Monomials are just products themselves, so we have products of products. We can basically mix up the multiplication. It doesn't matter. Order and grouping doesn't matter because multiplication is associative and commutative. So I'm just going to rewrite it like this so you can see it doesn't matter what order I put it in. I still have this 9x cubed yz cubed in my denominator, and you can see that I get here 36x squared y divided by 9x cubed yz cubed. At this point, we now have the quotient of two monomials. So the same way that we did this product, we can do this quotient. And let's rewrite this fraction as rather a fraction or a product of fractions. And in particular, let's write a number fraction times a fraction involving the variable x times a fraction involving the variable y times a fraction involving the variable z. At this point, we can do some simplification. Notice that 36 divided by 9 is 4. X squared divided by x cubed is 1 over x. Y divided by y is 1. I'm just going to ignore that. And 1 divided by z cubed is 1 divided by z cubed. Now I can write this one simpler and say that my solution then is 4 divided by x z cubed. The next problem I'd like to talk about has to do with products with monomial parts. So let's read this question together. It says, rewrite the products as polynomial expressions. So right now you see we have products, sometimes a product with a monomial and a binomial, a product with a monomial and a trinomial, a product of a monomial and something that's not a polynomial, and again, a product of a monomial and something that's not a polynomial. But that's okay. So let's, in the end, they should have all be polynomials though. So that's a good check for us too in these last two problems. Let's go ahead and begin with part A. So when we multiply monomials with polynomials or monomials with other expressions that have more than one term, what we'd like to do is distribute the monomial. So notice that 3x times x plus 1, what we can do here is we can distribute the monomial 3x to the first term of the binomial, x, and also to the second term of the binomial. Or in other words, we could say that this is like 3x times x plus 3x times 1. Or just 3x squared plus 3x. And that'll be our solution here. So again, all we need to do is multiply the monomial with each of the parts of whatever we're multiplying with. So let's look at part B here. We have the product of the monomial x with the polynomial x squared plus 7x plus 6. So again, what we'll do is we're going to distribute our monomial to all these terms. And what will we have? Well, then we have x times x squared plus x times 7x plus x times 6. And if we want to go a little bit further and simplify this, we could say this is x cubed plus 7x squared plus 6x. And that is going to be our solution. Now let's see something a little bit different. Now we're doing, rather than a monomial with some sort of polynomial, a product, we're doing a product with a monomial and something that's not quite a polynomial, because we have these variables in our denominator, or we're dividing by variables. We have negative exponents with our variables. In any case, let's go ahead and multiply this the same way, and that way is we distribute our monomial to both terms of this expression. So, notice I could write that this is the same as 2xy times xy. I'm going to put this minus sign because we're minusing. Now we have a 2xy times y over x. At this point, notice that we're doing products of things here. So we have the product of 2 and x and y and x and 1 over y. Notice that y and 1 over y are reciprocals, so they'll cancel. They'll multiply to 1. So what we have in this first guy here, in this first term, is 2x squared. And similarly, in the second guy, the x in my numerator and the x in the denominator will cancel, multiplying to 1. So I'll minus 2y squared as my second term. And that'll be the solution to part C. Finally, we have part D. And once again, we're just going to distribute the monomial into this 3-term algebraic expression. To do this, we start to multiply. Let's write that we have 6k times 1/2 k plus 6k times 1/3 plus 6k times 1 divided by k. So here, what can we do? Well, we have 6k times 1/2 k. We could reorganize this. Say that this is 6 times 1/2 times k times k. 6 times 1/2 is like 6 divided by 2. So that's going to be 3k squared. Then we have plus 6k times 1/3. So 6 times 1/3, that's the same as 6 divided by 3. That's 2k. And then we have this 6k times 1 over k. And so notice here that k and 1 over k are reciprocals. So we can say that this is just plus 6. Notice here that we have our solution. The next problem I'd like to discuss is having to do with addition and subtraction of polynomials. Let's read the problem together. It says add or subtract and simplify. In this case, you can see in the first we'll be adding polynomials, and the second we'll be subtracting polynomials. So to do these problems, what we're going to do is we're basically going to distribute the negative, if we have a subtraction sign, to all the terms in our second polynomial, and then just really putting terms together, or combining like terms. For example, in this first guy, we'll combine x squared and x squared, 2x and 4x, and negative 3 and 4. So really these are one-liners if you want them to be. I'm going to rewrite one step where I just write like terms beside one another, and also distribute the negative in the subtraction case. Let's do this first one here. Notice that I'm going to write x squared plus x squared plus 2x plus 4x minus 3 plus 4. You see I've written this, as I said, with the like terms beside one another. We can combine like terms. If we have an x squared and an x squared, we have 2x squared. If we have a 2x and a 4x, we have a 6x. And if we have negative 3 and positive 4, we have positive 1. And that will be our solution there. Let's look at part B. Now we have the subtraction of polynomials, or the difference of polynomials. So what I'll do is I'll rewrite it with the similarly how we have the like terms beside one another, and additionally I'll distribute this negative sign to all the terms in my second polynomial. Notice I could write this then as x squared minus x squared minus 4x minus 5x plus 4 minus 6. Okay? I can simplify these. X squared and x squared and negative x squared are additive inverses. They go to 0 when added. I won't write anything for that. A minus 4x and a minus 5x make a minus 9x, and a positive 4 and a negative 6 make a minus 2. And so there's our solution. The next problem I want to talk about has to do with multiplication of polynomials. In particular, it has to do with the multiplication of two binomials using the FOIL method. To remind us what the FOIL method is, FOIL is an acronym that stands for first, outer, inner, and then last. And in particular, the first, the products of the first terms, the outer terms, the inner terms, and the last terms of two binomials. So for example, let's read this problem here. It says, use the FOIL method to multiply the products of binomials. In part A, we have the product of the binomial x plus 2 and the binomial x plus 1. So what we'll do here is we will multiply using FOIL, or by adding the product of the first terms. So the product of the first terms, that would be x and x, x times x, and adding that to the product of the outside terms, that's x and 1, the product of x and 1. Adding that to the product of the inner terms, that's 2 and x. And adding that to the product of the last terms, that are 2 and 1. So you can see here what we'll have. We'll have x squared plus x plus 2x plus 2. And then we'll have to go one step further to say that is x squared plus 3x plus 2. And that will be our solution right there. So, again, notice here that we have our product of the first terms, the product of the inner terms, the product of the outer terms, and the product of the last terms. And we're just adding all those together to multiply our two binomials. So this is the FOIL method. Let's look at B now. B has the product of x minus 1 and x plus 1. So let's use the FOIL method. Let's multiply the first terms in each binomial, that's x and x. Add to that the product of the outside terms, that's x and 1. Add to that the product of the inside terms, that's negative 1 and x. And add to that the product of the last terms, that's negative 1 and negative 1. You can see here that we can compute all these products. So we have x squared plus x minus 1, or just x squared minus 1. Great. So you can see sometimes the product of two binomials can be a trinomial. Sometimes the product of two binomials can be a binomial. Let's look at C. So we have x minus 2 times x minus 3. Let's compute by using FOIL. Let's find the product of the first terms. That's x times x. And add to that the product of the outside terms. That's x and negative 3. Add to that the product of the inside terms. That's going to be negative 2 and x. And add to that the product of the last terms. That's negative 2 and negative 3. You can see we can simplify this to be x squared minus 3x minus 2x plus 6. And one more step gives us our solution, x squared minus 5x plus 6. And there's our answer. Let's look at D now. So D, we have 2x minus 3 times 5x plus 1. So this product of binomials is a little bit different because we now have a product of a number in x in the position, in the first terms for each of our binomials, where in these other examples, our first terms were only ever x. So this one will be a little bit different. But that's okay. Let's do it the same way by multiplying the first, inner, outside, and last terms. First, outer, inner, last. I just realized I wrote this wrong. So I'm just going to fix that real quickly. Notice that that is supposed to be the outside and the inner. In any case, we can get back to this problem. So we do the multiplication of our first terms, 2x times 5x, and add to that the product of our outside terms, that's 2x and 1, and add to that the product of the inside terms. It's negative 3 and 5x. Oh, sorry, and and add to that finally the last terms, the product of the last terms, and that's the product of negative 3 and positive 1. So I can do some multiplications. Again, this is some practice multiplying monomials, which is pretty cool. 2x times 5x, that's going to be 10x squared. 2x times 1 is, well, 2x. Negative 3 times positive 5x is minus 15x. And negative 3 and 1 have a product of minus 3. We can see that we can simplify by combining the second and third terms in that expression. So we have 10x squared minus 13x minus 3. And that'll be our solution to part D. The next problem I want to discuss has to do with more practice multiplying polynomials. But in this case, we're going to do the product of two trinomials, or two polynomials of 3 terms each. So let's look at part A. We have the product of x squared plus 2x plus 1 and x squared plus 4x plus 4. So how would we solve a problem like this? The way we'd solve any polynomial multiplication problem. We're essentially going to take each term in my first polynomial and distribute it to every term in my second polynomial. So first I'll multiply, for example, x squared with every term in the second polynomial. Then I'll add to that the products of 2x in all these terms. And finally, guess it, I'll add to that the product of 1 with all these terms here. So let's get going with that. How do we do that? Well, we can write x squared times x squared. So distribute first. Add to that x squared times 4x. Add to that x squared times 4. Add to that, now we're on to our green terms, our 2x terms. So we'll add to that 2x times x squared plus 2x times 4x plus 2x times 4. Onto our red terms. Plus, I'm going to put it down here because we're running out of room, plus 1 times x squared plus 1 times 4x plus 1 times 4. Okay? So this is a big old long thing, but it's something that we can simplify and find a solution for. So let's start to do some multiplications. We have x to the 4th plus 4x cubed plus 4x squared plus 2x cubed plus 8x squared plus 8x plus x squared plus 4x plus 4. Whew. Okay, so now what can we do? Well, we can start to see where like terms can combine. We have powers, 4th powers, 3rd powers, 2nd powers, single powers, and 0 powers of x. So let's combine the like terms we see. So we see that there's only one x to the 4th. So that's an easy guy to go. X to the 4th. Let's just put all the x cubes by each other. How about that? So then we have plus a 4x cubed plus a 2x cubed. That's all for cubes. How about for squares? We have 4x squared. We have 8x squared. We have x squared. What else? Let's go to x's. Now we have 8x and a 4x. And finally, we just have a 4. Now that I've rewritten this, maybe it's really easy to see that we can just group these things. So we'll have this group here, x to the 4th powers, a group of 3rd powers, a group of squares, a group of single powers, and a group of constant terms. So this is just a nice way for us to visually see where all these terms are going. To simplify this then, we have our x to the 4th. 4x cubed and 2x cubed makes 6x cubed. 4x squared, 8x squared, x squared, that makes 13x squared. 8x and 12 or 4x make 12x. And finally, we have that plus 4 still. And so our solution to part A is this big long polynomial of 5 terms. Part B. Let's see. what we have here. We have the product of two trinomials. So again, we're going to do the similar thing we did here, where we're going to just distribute all these terms through. I'm just going to erase this problem now, so we don't have to look at that. And I'm going to put those same lines on this trinomial. So the first thing I'll do is I'll multiply x squared times x squared. I'm going to write these as I go. So this is x squared times x squared. I'm going to add to that x squared times 2x. And I'm going to add to that x squared times negative 15. Great. Go on to my next term, negative 5x. I'm now going to distribute negative 5x to all terms here. So notice that I'll have plus a negative 5x times x squared plus a negative 5x times a 2x plus a negative 5x times a negative 15. All right, and finally we'll distribute this negative 6 to x squared. That's going to be plus negative 6 times x squared. Add to that negative 6 times 2x. Negative 6 times 2x. And add to that negative 6 times negative 15. Great. So if we combine, I'll put little dots right here so you know we're continuing on all these lines. This is one single line. And we can maybe write all these lines in a single, or all these terms in a single line and begin to simplify. So notice, starting from the top, we have x to the fourth plus 2x cubed minus 15x squared minus 5x cubed minus 10x squared plus 45x minus 6x squared minus 12x plus what is that? 6 times 15 is 90. And you know what? Did we do this multiplication here right? What is negative 5x times negative 15? That should be 65x. Let's fix that now. Not 65, I messed it up again. 75x. Great. Okay, so we've caught our mistakes. We've written all these terms in one line. Let's start to combine like terms. At this point, I'll choose to rewrite these so all the like terms are by one another. So I have x to the fourth plus 2x cubed minus 5x cubed. That's all for cubes. Let's go to squares. Minus 15x squared minus 10x squared minus 6x squared plus 75x minus 12x plus 90. So you can see here what we've done is we've chosen to, again, just group our terms, our similar terms. We've written all of our fourth powers by each other, all our third powers by each other, all our second powers, all our one powers, all our zero powers. And what we can do at this point is just combine those like terms. And we can say that this is the same as x to the fourth minus 3x cubed minus 31x squared plus 63x plus 90. And that's our solution there. The last problem I want to talk about has to do with multiplying polynomials, and in particular not multiplying two binomials or just two trinomials. Something different in this case, where in both cases we're multiplying a binomial and a trinomial in different orders. But I just want you to know that you could do this with, or these operations, distributing each term of the first polynomial to every term of the second polynomial, and doing this for all terms and summing them. You could do this for any amount of termed polynomial. So you could have, 100 terms, and you could still do this. But in any case, we can do this with just this binomial times a trinomial. So what we'll do, again, is we're just going to distribute every term in my first polynomial to every term in my second polynomial, and I'm just going to add all the products. In other words, let's start with x and distribute x into x squared. So that's going to be x times x squared. Then x into 7x. Well, that's just going to be plus x times negative 7x. And add to that x times 6. Okay. And now we can go on to our next term in our first polynomial, which is 1. So I can multiply 1 and x squared. I can multiply 1 and negative 7x. I can multiply 1 and 6. And you can see now that I've completely multiplied these polynomials. So what I'd like to do at this point is I want to combine these lines, or all these terms, and find these products. So notice that we have x squared minus 7x squared. Oops, I'm sorry. This should be x cubed. X times x squared by the power rule would do 1 plus 2. That would be x cubed. Minus 7x squared, that's okay. Plus 6x plus x squared minus 7x plus 6. Sweet. At this point, we can see we just need to combine like terms to simplify this problem. In particular, we have this like term, negative 7x squared and x squared, and also this like term 6x and negative 7x. So what I'll do then is combine those terms and write this is equal to x cubed minus 7x squared and x squared make minus 6x squared, and 6x minus 7x make minus x, and then I just have that left over plus 6. So I can see this is my solution. Let's see part B. So part B, we have a product of a trinomial and a binomial. And this time the trinomial is coming first. I'm going to show you how we would multiply with a trinomial first. But notice that if we wanted to, we could rearrange this. And we could say that this is the same as 2x plus 3 times x squared plus 4x plus 4. So some people might prefer to distribute the terms of this binomial into the terms of the trinomial rather than distribute the terms of this trinomial into those terms of the binomial. In any case, we can do this. I'm going to do it with the trinomial first so you can see how that might look and how that might be different from the previous problem we just did. So let's rewrite then this problem. So we have x squared plus 4x plus 4 times 2x plus 3. And let's start by distributing every term of our first polynomial and making a product with every term in our second polynomial, and then adding all these products. We'll start with this x squared and distribute the x squared to the 2x. I'll distribute this x squared to the 3 as well. So I have plus x squared times 3. And now I'll move on to my next term, this 4x, the next term of my first polynomial, this 4x. And so I'll multiply 4x with 2x. And I'll also then, and I'll add that, and I'll also add and multiply, in this case, 4x and 3. And this brings us to the last term in our first polynomial. So we'll add then the product of 4 and 2x, and add then the product of 4 and 3. Okay. At this stage, we can start to perform some multiplications and see some simplifications. What do we have? X squared and 2x make 2x cubed. X squared and 3 make 3x squared. 4x and 2x make 8x squared. 4x and 3 make 12x. 4 and 2x make 8x. 4 and 3 make 12. At this point, we can see we have some like terms which we could combine. We have some squares that we'll combine, and we also have some just powers, first powers of x that could combine. If we do that, what will we have? We'll have 2x cubed plus 3x squared and 8x squared make 11x squared. 12x and 8x make 20x. And we still have that plus 12. And that's going to be our solution for part B right there.